Now we have another interesting material supplier, Cybrid, who was at one point of time the largest backsheet maker, but that quickly transformed also into the encapsulation material suppliers. And Cybrid is offering the entire polymer wrapping solutions for solar modules. We have Jacob Harris, who is overseas account manager at Cybrid. He is going to talk on advanced backsheet structures for latest cell technologies. Jacob, the floor is
Okay, thank
yours.
you everyone, and I'm very glad to be here with you today at Taiyang News. My name is Jacob Harris, and I am a client manager at Cybrid Technologies Inc., based here in China. Let me go ahead and share my screen. Is everyone able to see?
Yeah.
Great. Okay, so Cybrid is an applied materials company based in China in Suzhou, just right outside of Shanghai. Founded in 2008 with venture capital investment. Our ambition is to become a world-leading comprehensive polymer material solution enterprise, providing not only materials, but also service and consultation on material application, processing technologies, and providing high value tailored solutions to all of our clients. So in the field of photovoltaics, we have long had a leading position with the groundbreaking invention of the KPF backsheet, which was a top-selling product for 6 consecutive years. Our company slogan is valued by innovations, and we address technical challenges in many different industries, with PV being the largest. So our founders were experts from the Japanese polymer materials industry, and they started Cybrid after resigning from 2 top companies. Soon after inventing coating and lamination technologies that facilitated the KPF backsheet, as well as cross-linking POE film, maintenance solutions for modules in the MoPro applied materials solutions line. And now we are also doing a lot of industrial tapes, electric vehicle, battery packaging films, and we've established a unit overseas and recently launched one of our most exciting products, which is the Rabo UV conversion film for HJT and TOPCon modules. In terms of PV innovations, we've long addressed some top concerns of the industry. When we first started, there was a big shortage of backsheets due to previous backsheet technologies relying on specific films, which had to be laminated to PET, where our new technology introduced new lamination techniques and quickly gained a very big market share. As time progressed, we also got big into the encapsulants industry, and with new industry trends, we are developing technologies for lightweight modules and recyclable encapsulants. So it's a very exciting time to be in the PV industry. And we are rapidly expanding into many other industries as well, such as automotive, consumer electronics, and other areas as well. So we're very grateful to all of our existing partners that we work with in the PV industry, and it's always exciting to meet with them and discuss their specific cell technologies and find ways to improve our material solutions for their specific needs. So let's get started. I just have a few products that I wanted to discuss with everyone today. A couple of them being backsheets, and then also wanted to go over reflective gap films, which are an emerging alternative to screen printing on glass for PV modules. And all of these solutions that we are discussing today are for emerging cell technologies such as TOPCon and HJT. And we have also been doing a lot of good solutions for PERC cells as well. So I think the KPF backsheet from Cybrid is quite well known in the PV industry. But something less known is probably the PPF backsheet. This backsheet, instead of having a fluorine film on the outer layer, actually has a co-extruded 2-layer PET film, with the inner layer being a standard PET. The outer layer is a reinforced anti-UV weather-resistant PET, which has shown really good performance in our weather tests, with the inner layer being our proprietary coating for high reflectivity and long-term color stability. I want to talk a little bit more about the coating specifically in my presentation today to place a little bit more emphasis on the value that that provides. So traditionally in a black backsheet, you are absorbing all of the, or most of the light, which is it is exposed to. So this was basically a carbon black coating, where this is a newer version of the coating that we call organic black, and it is special since it absorbs visible light, but also allows infrared light in that area of the spectrum to pass through, increasing the efficiency of cells. Previously, this was only possible with white backsheets, but if you notice the difference on this graph here, standard black backsheets are the red line, which stays flat. High reflective backsheets is the purple line in the middle. You see after about 800 nanometers, there is a big increase in reflectivity. So for markets where black modules are preferred, this is a really good option to increase efficiency through the special coating technology. Here in this graph, we're showing 3 types of modules. The red and green are using Cybrid black high reflective backsheets, where the black one at the bottom is a standard black backsheet. This backsheet technology is available with the co-extruded PET film and the coating applied in a grid pattern, or as a fully solid black, which is the red blocks. So it's showing a efficiency gain of about 7 watts per module, or about 1.7% roughly, with both the grid and the solid black reflective backsheets. So this is a really good way to squeeze in those extra watts on your modules. And it maintains a really good black consistent appearance that merges really well with the appearance of the cells laminated on the front side. A concern of many module producers is the color stability of their black backsheets, but with our specially formulated coating, we were able to address some of that by offering a really stable black backsheet that will maintain that sleek jet black appearance over a longer period of time. We performed several tests, including a 150-degree test, baking test for 48 hours. And this was laminated on glass and POE or EVA encapsulant with the backsheet at the base layer. So compared to competitor products, there was very minor discoloration. As you can see, these images were shot in the same conditions, and this is the LAB value with the specifics of the color stability shown if the images didn't do it justice. But basically, that's very important to not have your black colored backsheets fading over a longer period of time to create that jet black appearance for good quality. And here is a graph of our backsheets in the green dots with the competitors in the red dots for the color stability with the optical color tester. The second type of backsheet that I want to briefly touch on here is our water barrier backsheet. So at the very top layer, there is an anti-UV layer of PE followed by an adhesive. And with the specially formulated water barrier primer, we were able to achieve very low levels of water vapor transmission, laminated onto a core layer of PET with the standard F coating, which is also one of our inventions facing the cells. So this has about 0.05 grams per square meter per day of water transmission, which is very low, and is an important consideration for TOPCon and HJT modules. So this is one of the products that we've been recommending to a lot of our clients recently. And the water barrier primer technology on PET service also has no negative effect on transparency. So this is a really good option for transparent backsheets, which are becoming extremely popular in the industry for a variety of reasons in these emerging cell technologies. So it's a really good option for clients to consider who are trying to extend the lifespan of their modules, since water ingress does cause a big threat to the stability of the electrical components within modules. So that's all of the backsheets I wanted to introduce today. And let's go ahead and move on to our next couple products, which are gap films. So for grid patterns in modules, long established method has been screen printing the grid patterns onto the glazed glass. Unfortunately, there is some added risk with this method, since during the glazed glass production process, there is some heat transfer onto the surface of the glass, which can be transferred unevenly when there is that coating pre-applied on the glass. So the problem with this is it can affect the mechanical properties of the glass in the long term. So a new solution is to use the gap films instead of pre-printed glass on your modules. And in one particular case study, there was a large module manufacturer who was producing modules with screen printed glass, and they had a big contract with a power plant, multi-gigawatt installation. And basically, after being installed for 6 years, suddenly a bunch of the modules all cracked mysteriously, simultaneously. And what the producer of the modules was able to trace this problem back to was the glazing process with the screen printed patterns on the glass. So to improve the mechanical properties of the tempered glass, it's more ideal if you can buy your glass blank and apply the films to create the gap cover patterns. The gap films are able to be applied directly to glass or backsheet, as they have a base layer of EVA, which is seamlessly laminated into encapsulation films. And it reduces the added instability caused by heat transfer onto the glass during the glazing process. So traditionally, a lot of gap films in the industry have been metallic. And while this is a good solution, there is some additional cost. So the new solution that Cybrid is offering is going to be some non-metallic gap films, available in both white and black. So the metallic gap films have reflectivity of about 80%. while the white gap film is offering a reflectivity of 82% and slightly lower with the black film as well. So the metallic film has the metallic foil on the top layer, followed by a coating of primer, PET, primer, and then a base layer of EVA, which is important for lamination into the panels. The metal film does have a little bit higher of a cost, but it is still a good way to increase efficiency while reducing the costs of module production. Here's the structure of Cybrid's white non-metallic gap film. So on the very top layer, there is a coating which offers high reflectivity for increased power efficiency, a base layer of PET, another coating between the base layer and the EVA, which seamlessly integrates into the lamination. And between the wavelength of 400 to 1,000 nanometers, there is a reflectivity of 82%. So the next one is going to be the black non-metallic gap film, which has different coatings, but still offers really good reflectivity at 62%. And as I said, these can be applied to blank glass by a fully automated process, and improves the mechanical properties of the glass over the long term, and also adds good rebound resistance to the modules. Here is a comparison of different application solutions of residential 54 cell TOPCon modules. The first two being a single glass module, the second two being dual glass modules. At the very bottom, we have a dual glass module with black gap film utilized, and there is a cost reduction of about 2.6 RMB per watt in the backsheet, in the module production cost, which is a good reduction over the screen printed glass option, the third to the bottom, or the second from the bottom. And as we can also see, there is little difference in the power of the modules as well. So these are really good options for reducing costs and improving strength over the long term of your modules. The gap films can be applied via a fully automated process. It's compatible with float glass and embossed glass, as well as backsheets, and can be done for various types of cells, different brands of machinery, and has a pasting accuracy tolerance of 0.2 millimeters, taking 16.5 seconds per piece with a capacity of 40 megawatts per month. And the length of the equipment is 9 meters. So it's a very good option to seamlessly integrate into your fully automated process. Anyways, that is all I have for you today, you guys. If you have any questions, feel free to ask in the chat and I will answer for you. And we will also be talking more within the panel discussion. So thank you all for listening. Do you have any questions for me?
Yeah, thanks, Jacob. So one
no
question
problem.
I have is, which glass are you recommending in case of a double glass? Are you recommending to put the reflective film on the front glass or the rear glass?
So this can be applied to the front glass to cover like wires and components. In case someone wants to make a double glass black module, for example, if that's their preference, this is a good option to do that.
And what about the equipment? So is it coming from Cybrid, or you have any preferred partner, or this is just an open equipment
The
like
processing
Cybrid?
equipment, you mean?
Yeah.
We do have like a preferred partner. Um, there are a few different options that we can recommend.
Yeah.
Yeah.
Great. Yeah. So please stay online and answer if there are any questions in the chat window till we meet again for the panel.
Sure, no problem. Thank you so much.
Thank you.